Okay, there we go. Okay, there we go. Alright, so when we last left off, we were in the middle of multiplication world, and I got pretty stuck on this question. So we need to prove that the successor of A times B equals A times B plus B. And it gave us the hint that we should look at the last level from addition world. And when I go and look at that, number 5, it had us use the associative property and the commutative property. And now the reason that confuses me a little is because we're doing multiplication now. And we can't really use, we have not yet proven that multiplication is commutative or associative yet. We can do that for addition, but not for multiplication yet. So that's where I got stuck last time. So let's see. So we started with the successor of A times, so the original question is the successor of A times B equals A times B plus B. So, and then I use the commutative property to switch the A and the B around there. Or, yeah, because we're adding B to B. And now we're adding B plus A. And then we used this. We turned the successor of A into A plus 1. Now, I don't actually know if I'm on the right track with that. But let's... So what else can I do? There's no zeros, so the zeros can't help me. So we've only got proof that something times 1 is itself. And the proof that something times the successor of something equals those two things multiplied plus. Yeah, plus A. Okay. Let me start over. So we have induction, reflect, and rewrite. I'm not sure if we can use induction. I'm not actually positive if this is. You know what? Perhaps we must go backwards before we can go forwards, because I'm pretty stuck on this one. So let's do these 2 questions. Let's start multiplication world over. So just so I can get back into the swing of it. Oh, well, it's already showing us our answer. But for this one, we needed to prove that something times 1 equals itself. And I started with... I turned 1 into the successor of 0. Oh, and then I used multiply successor. I used that to turn this from... from this into that. And then I suppose I got rid of the 0. And once I got rid of both zeros, yeah. So let me redo this. So I started with rewrite what was it? Yeah, it was 1 equals the successor of 0. Then we went ahead and we used this, rewrite multiply successor. Yep, that makes sense. Okay. And then, oh, then what did I do? Oh, multiplies by 0. So, nope, the other one. Multiply 0. So anything times 0 equals 0. Rewrite multiply 0. And now all I have to do is rewrite add 0. Nope. We want 0 add. And then we can reflect. Let me delete this without looking at it so I can get back into, I can warm back up. So we want to prove that 0 times m equals 0. Oh, that's this one here. So yeah, it's been added to our list because we've done it already, but I want to do it again. Where do we start? Where do I start? Oh, hang on, I want to see. I did use induction for this one. Okay. Induction M. So now, if it's 0, we know that anything times 0, we can use this. This first one, anything times 0 is 0. Whoops. That one's done, and now we need, for the case in which m is not 0. The case in which m is a number, and a number is always a successor of a number n. So we got to turn successor n into n plus 1, I think. Yep, this one. Now what do? I want to get it to look like this so I can use the induction hypothesis to prove it. But how do I get this n plus 1 to just be n? Not that one. Oh wait, commutative maybe? No, the associative. And that can change the order of the parentheses. No, that's not it. What about commutative? Whoop, that did something. What did it do? Oh, it just switched these around. I don't know if that helps us. Well, how do we do this? I don't think that helps us at all. The successor of n can be made into n plus 1. Would this do anything? No, that's not it. That didn't work. That didn't work. Wait, any of these? Oh wait, I think it is one of these. Yeah, anything times the successor of anything can be turned into those two things multiplied plus one of the things being multiplied. So I think get rid of that. We don't want to turn this into n plus 1. We want to use this maneuver. And now we've turned that from 0 times the successor of n into 0 times n plus 0, right? And now I can use that induction hypothesis. And now we can use the fact that anything plus 0 is 0. And we can just reflect. Oop. Yeah. All right. Now we're back to where we were, where we got stuck. I'm thinking now then that I should try and use induction on this one. But which letter do we want to do the induction on? I'm not sure how I would decide that. Well, let's try one of them. Let's induction B. And so now we've turned it into a times 0 time equals a times 0 plus 0. Oh, well, we can get rid of this other 0 by just doing rewrite add 0. We could also do 0 add, and that would do the same thing. And reflect. Did that? Oh, no. My eyes glazed over this. It's the successor of A, and then we have A over here. Okay, so that's why that's not working. They're not equal on either side yet. But all I should have to do is use this one. No, it's the opposite. Oh, right, if I had the opposite of this, then that would just immediately help us with this, because that's what we're trying to make here. We need to get successor multiply, the opposite of this one. That's the whole thing we're trying to prove here. So if I had that, then we wouldn't even need to do any of this. What else can I use? Multiply successor. Oh, I could use anything times 0 is 0. Oh, there we go. And then the opposite one as well. Oh, no, just the same thing again. So we can do it in the same line even. And 0 equals 0. So, reflect. There we go. Now, this is where we ran into trouble. So the successor of A times the successor of N equals A times the successor of N plus the successor of N. Nothing's being multiplied by 1. I could use this. This one would work on this one here. Geez, if you highlight things. Wait, what? Oh. Okay. Rewrite multiplier. Wait. Oh, that didn't change the one I thought it would. I'm sure I did the exact same thing yesterday. Okay, so it does work for this. The successor of A times the successor of N becomes the successor of A times N plus the successor of A. But I could do it again, right? Yep, and that turns A times the successor of N into A times N plus A. Oh. What next? I can use the associative. What did that change? Oh, that put these in parentheses. Hang on, I should be trying to get it in this. The successor of A times N equals A times N plus N. Huh. Oh wait, if I go back a little. Maybe the successor of N, this is suspiciously close to this, I think. Somehow if I can get the successors of N to just become N. But I don't know how to do that. The successor of A times N, which we're very close to having here. Wait, maybe I can use it anyway. Maybe the fact that this is here doesn't matter. Wait, let me just do that. Let me rewrite using our handy-dandy induction hypothesis. And there we go. Yeah, it worked for here. A times N plus the successor of A equals A times the successor of N plus the successor of N. Okay, that works, but I'm not sure what else to do. What else? What else can I do? Is there anything I can do about this successor of A? Let me think about that. Wait, it says we should use associative and commutative somewhere in here. Or at least one of these. That's the hint here, the last level from Edition World, which used these heavily. And I haven't used them yet, so there's gotta be something I can do with them. But let's see what I was gonna do. I was gonna do... I could try that. And that changes the successor of A into A+1. And if I did it 2 more times, can I use repeats? I thought there was a thing. Why does... when it's got all 3 of these highlighted here, successor A, successor N, and successor N, but then it only affects the first one. And what is this? What is this doing here? Can I do this? There it goes. Oh, I only have to do it 1 more time. Okay, so that's something. What else can I do? A times N plus A+1. I'm pretty lost at this point. There's no successors left. I don't know if I'm on the right track. a times n plus n, and a times the successor of n plus the successor of n, and the successor of a. It feels like I'm onto something here, but I don't know how I make these sides equal. This one? Okay, that did something. Hey, we have a times n. It's not the successor of a times n, so we can't use this. But we do have a times n and a times n's. We're closer. And we have a over here. They're closer. They're closer than they were. We have a times n plus n, a times n plus a plus the successor of n. So we have a and the successor of n on this side, and we have n and the successor of a on this side. So I feel like we're really close. We're so close. Can I... Wait, there's something that I can do with... No, not that one. Something plus the successor of something equals the successor of both of those things. Oh, that's it. That's it. Wait, I think I got it. All I need to do, we have n and successor a and successor n. All I have to do is switch around one of those using the commutative. Yeah, the commutative property. Rewrite with add commutative. Wait, I'm not sure that did what I wanted it to do. I want it to switch around these two so that it's plus the successor of a, or else I want it to change around these two so the successor of n and a can be there. Can I specify which ones I want it to change? No, that doesn't work. Hang on. I'm gonna go back. Where did it say there is one point in which it gave me advice telling me that I could... That might have been back in here in Addition World. this here. For example, rewrite add commutative b will only do rewrites with b's in them. So I only want to change the actually that doesn't really help me because it's oh, a times n plus n, a times n plus n on this side. Okay, so all we're doing is we're taking this and sticking it over here. I don't think that's helpful to me. I'm pretty sure I've almost got it. If I can just get... Maybe I don't need to switch them around. What's the thing? Is this the successor of something plus 1? No, nope, not that one, not that one. Wait, what is this? No, that's not what I'm looking for. What am I looking for? This one. Plus the successor is the successor of both of those things together. Oh, and then I think afterwards I can use the commutative property. Rewrite. Add successor. That didn't do exactly what I thought it would do. All I wanted for it was to do this one here. Wait, n plus the successor of a becomes the successor of a times n plus a. If I do that again for the other one, oh, we're so close, we're so close. A times n plus a times n plus a plus n. All I need to do is switch these two around. Rewrite, add, commute. No, am I doing the wrong one? I thought it was this one. Should I do the associative? A times n plus a times n plus a plus n. No, I was right. The associative is what we want. What if I use this first? Oh, that did it. That's the one I wanted. Wait, what? Is the proof that a plus b plus c equals a plus c plus b. And so it turned our n plus a, oh I see, into n plus a plus n. And now, if my eyes do not deceive me, those are equal on both sides. Yes! We did it! Oh, nice. All right. Next one. All right, the first boss, the first sub-boss of Multiplication World is multiply. Why is the word escaping me? What? Commutative, that's what it is. So we're going to prove the multiply commutative theorem. When you've proved this theorem, we will have spare proofs such as zero multiply, which is now easily deductible from multiply zero, but we'll keep hold of these proofs anyway because it's convenient to have exactly the right tool for a job. Okay, I see. Alright, we want to prove that a times b equals b times a. We're going to prove that multiplication is commutative, which is pretty cool. Okay. Where should I start? I guess it's going to be an induction. Does it matter which one we do? A? I guess we'll try A. Induction A. So we're going to prove that 0 times b equals b times 0. And that should be pretty easy. We can just use 0 multiply, right? Yep, 0 times anything is 0. Rewrite 0 multiply. Okay. Oh, and then we'll do the opposite one as well. Rewrite multiply 0 and reflect. Now we need to prove that the successor of n, now we need to prove the case in which a is a number. So we should be able to use, we have successor multiply and we have multiply successor. And that should be all we need. Rewrite successor multiply. And then the second one will be multiply successor. Now we have n times b plus b and b times n plus b. Now what? We have the induction hypothesis that n times b equals b times n. Oh, there we go. We just need to do that. Right. I always forget to look at this. And that looks right. There we go. We just technically proved that multiplication is commutative. Though I don't claim to actually understand exactly what we just did. I feel like I need to walk through it very slowly on my own, or on my own time, and try to actually understand why this proof works. But yeah, anyway. Next one. You can prove that 1 times m equals m in at least 3 ways, either by induction or by using successor multiply or by using commutativity. Which do you think is quickest? I'm guessing commutativity is quickest. Or maybe, wait. The proof that a times b equals b times a. Yeah, so I can switch the 1 and the m around using rewrite, multiply, commutative. And then we already have a proof that anything times 1 is 1. And then we reflect. Now, that one was so easy, I want to try it the other ways now. You can use successor multiply in order to get it. What does that one do again? It proves that the successor of something times its something. The successor of a times b equals a times b plus b. Now, why does that work here? We don't have a successor. Oh, we can make it the successor. We can turn 1 into the successor of 0. And now we have a successor. So we rewrite with successor multiply. And now we can use the fact that anything times, or 0 times anything is 0. And we can do the same thing with add. And that's that. Now this one is a bit longer, so far my theory that commutativity is the quickest is holding, but let's try the last one. You can prove it by induction, which I think induction always takes a little bit, so I think I'm correct that commutativity is the quickest one. But let's try this. Induction M with, I guess you can type whatever you want, F XD anything times 0 is 0, so rewrite multiply 0, and yep, reflect. Yeah, and so now we've set it up so that our number that we're using is F, and our induction hypothesis is named XD face. So there's that, I guess. So 1 times the successor of f. Ooh, I know a thing we can use. Oh, we want the opposite of this, successor multiply. We want multiply successor. There we go. 1 times the successor of something. Oh, and now we can use our XD hypothesis. Oh, and f plus 1 is, of course, the successor of f. So, and we can... Where is it? This one? Yes, actually, we just need to do it backwards. We need to use the backslash arrow of this. And that's turned the successor, yeah, that turns it into the successor of f, because we're going through it backwards. We wanted to turn this into this instead of this into this. So we use this arrow to run this backwards. And we can just reflect. And that's, so I think I was right that commutativity was the quickest way of doing it. Because that was just... I mean, I already forgot, but... Yeah, you just use this to switch around the 1 and the m. Then you use multiply by 1 to prove that anything times 1 is itself, and then you reflect it. It's literally 3 steps. That seems to me the fastest one. So that's the quickest. Anyway. This level is more important than you think. It plays a useful role when battling a big boss later on. It's a secret surprise tool we'll use later, as the meme goes. Anyway, 2 times m equals m plus m. Oh, okay. To multiply for any natural number, anything times 2 equals that thing plus itself, I guess. So how am I going to do this? Do I need to use induction? I don't know what else I would do. I don't know how to turn a multiplication into... Or wait, maybe I do. Would something like this possibly do it? Let's see, rewrite 2 equals the successor of 1. And now we have a successor times a thing, just like we would need in order to use this. Rewrite whoops. Now we have 1 times m plus m. We are on the right track. We just need multiply 1. Oh, over here. Or 1 multiply. Yep, 1 times m equals n. 1 times something always equals itself. Oh, and that's what we proved just last round, just last level. So we're gonna use this newly acquired, what did it call them? Lemmas? I think, yeah, it called them lemmas. An intermediate proof that you can use in a bigger proof. Yeah, so 1 multiply m plus m equals m plus m. Easy. Wow, this is going better than I thought it would. Watch me jinx it. Oh goodness, what is... Our next goal is left and right distributivity. Yeah, I can read. Distributivity, meaning A times B plus C equals AB plus AC and equals AB plus AC and B plus C times A equals... Hang on, I'm tripping over myself. Okay, so A times B plus C equals AB plus AC, and B plus C times A equals BA plus CA. Rather than these slightly pompous names, the name of the proofs in Lean are descriptive. Let's start with multiply add, ABC. The proof of A times B plus C equals A times B plus A times C. Note that the left-hand side contains multiplication and then an addition. You can do induction on any of the 3 variables. Some choices are harder to push through than others. Can you do the inductive step in only 5 rewrites only? Okay, so that'll be our challenge once we figure it out, is to try and do it in only 5 rewrites. Okay, I get it. A times B plus C equals A times B plus A times C. So we're, distributing it just like you would in algebra. Or I don't even know if that's algebra. Okay, where should I start? Induction. Induction, I guess we'll go with A. So 0 times anything. Nope. 0 multiply. There we go. Oh, but we want to do that again. And again. Can I just repeat it over and over again? I don't know why that isn't working. Repeat. But what's this mean? Why is this here? Why doesn't it just apply it to this? I don't know. Anyway, that works. Does this count as 3 rewrites? I guess it does. And then rewrite, whoops, add 0 and reflect. That was 4 rewrites. I don't think we're going to be able to do the rest in only 1. Okay, this is nearly this, except that we have the successor of n instead of n. And same thing here. I could run this to turn this into this. Except that this is successor n instead of n. So all I need to do is somehow turn all of these successor n's into n's. What can I use? Let me think. What do I use? Can I use this? Will this do anything? Yes. Oh, okay. That did something. Oh, and now we have this way. Now, what does this do again? This takes the successor of something. The successor of A times B becomes the successor of A times B. It becomes A times B plus B. Right. Can I do it again? Oh, hang on. Let's leave that for now. I can use my induction hypothesis now. And now we have n times b plus c times c plus... I feel like that was simpler before. We're getting somewhere? Maybe? n times b plus n times c plus b plus c equals n times b. We have, at least we have n times b on both sides, but then it immediately breaks down. Well, that did something. There's so many variables at this point. It's so hard to, like, comprehend all of it. What did this do? We went from n times b plus n times c, n times b plus n times c. Okay. All we did was take this and put it at the beginning instead. That's all that did. What if I try? That just added a parentheses. No, I'm pretty stuck on this one. I'm pretty stuck on this one. I figured out, I got to the point where I could use this. So that feels like I'm on the right track. But now I don't have any idea what to do. B plus C plus B plus C. N times C plus C. What can I use? There's no numbers in here, so there's no successors. Or no known numbers, at least. Oh, there was, before I got rid of them. Right. Right, we wanted to get rid of the successor of n so that we could turn this side into this, and this side into this, and then, of course, we could use this to turn this side into this, and then they would be equal. But getting rid of the successor was more difficult than I thought. I'm not sure I used the right thing here. Successor multiply. That does take in a successor and a multiply, and it's anything else I can use? It looks so close. From this point, at least. Wait, we do also have some additions in here. We could use b plus the successor of n. What do I have for that? Wait, it won't. What? It doesn't work? A plus the successor of b. That's this right here. But I guess... No, because it's the successor of n times b. Right? It's the order of operations. Okay. Oh, it seems like we're so close, but then it all falls apart. What do I do from here? If I can just get rid of the successors on all of these n's. I don't want the successor of n, I want n. What? Oh, what happened? Okay, I think we're still good. So the stream gave me a notification of something. Anyway, we can turn the successor of something times that something else into those two things multiplied together plus the thing it's being multiplied by. Which definitely seems right, like the right option. It turns it into this. This one is certainly giving me trouble. We could turn the successor of n times b into... That would turn this into n times b plus b, right? Yeah, n times b plus b. And then if we did this last one, it would turn the successor of n times c into n times c plus c. Now if we just had a way to turn the n times b, we have b by itself, we have n times c, and we have c by itself. which we do have over here. We have n times b and n times c, which is n times b and n times c, n times b, n times c. And then we have a b by itself and a c by itself, which is this one and this one. So we're closer than we think, or we're closer than I thought I was. But what can I do? Oh, I can open this up into, I can use the induction hypothesis to turn this into an n times b and an n times c. So that seems like, yeah, okay. I think this is what I had already, but I didn't know what I had. N times b, n times b, n times c, n times c, b, b, c, c. They are the same. I just need to somehow change the way the equations are written, which I assume we can use. Do we need to use commutative? Is it only additions that are needing to be moved around? We have b plus c, we have our b and our c. Yeah, n times c, n times b, n times c, n times b. We don't need to move around any of the multiplications. We just need to move around the additions that are adding the multiplications together. So I think we need to change our parentheses somehow. But I don't know how to do that. This is the proof that a plus b plus c is the same as a plus b plus c. It's just these parentheses. I need to somehow wrangle the parentheses into the right place. No. What did this do? That just added a parentheses. What happens if I try and do the backwards version of this? Does that do anything? It does. It gets rid of parentheses if I use this little arrow. N times b plus n times c plus b plus c. Hold on. Do it again. Yeah. Okay, we got rid of the parentheses. n times b plus n times c. Now I just need to get some of these switched around. In fact, I only need to get n times c and n times c. I want to get I just need to add commutative. Oops, now what did that do? No, that's not what I wanted to do. What if I just keep doing it? Just spam it. Oh, it just undoes itself. Okay, that's, yeah, right. I thought I could specify which. Okay. We're so close. We have n times b. We have the same things on both sides. They're just not in the right order. We have n times b, n times b, n times c, n times c, 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 and b, and b. I just need to move them around. Can I do nth? I can. That did something? Yes, I moved the third one around. We went from n times b, n times c to n times c and n times b. What if we move the fourth one around? The fifth one? N times c, n times b. The sixth one? N times b plus b. Hang on, what do we need to move around over here to get it? We have n times b, n times b. N times c is here. So I want to trade. I want b and n times c to trade places. That's not what happened, though. So now we took b and put it... Oh, so what add commutative does is it just takes one of these and puts them at the beginning. Huh. So if I say rewrite 6, then it'll take the 1, 2, 3, 4, or it'll take the 1, 2, 3, 4, 5, 6th one, b, and put it at the beginning. Whoa! And so yeah, it's there, b. So I don't think there's a way I can just tell it to switch n times c and b around. So let's instead try and make this, whoops, let's try and make this look like this instead of trying to make this look like this. I think that'll be easier. So we have n times b at the beginning in both cases. Wait, okay, I know exactly what I'm doing right now, but I just don't know the best way to do it. I just need to... Huh. Well, they're both... The first... The first part of each equation is already what I want it to be, because they already match. But add commutative seems to only be able to... Is there anything else I can use? There's add right commutative. What does that do? Oh, wait, this might be what I'm looking for? Is the proof that a plus b, parentheses a plus b plus c equals parentheses a plus c plus b. Let's see, add right. What'd that do? That switched b and c around, which is something that I needed to do, I guess, because b and c. No, b, c, b, c. That's actually not something I wanted to do. Hang on, back to this. There's just a certain order. I think we're well beyond 5 rewrites at this point. Obviously. Oh, but we're so close. I know we're so close. We're so close to getting this one. I just need to rearrange where they are. Nope. Wait, what? Isn't that what I had written before? Oh, I used a space instead of a underscore. Okay. Let's see, 1, 2, 3, 4, 5, 6. They're in the right order. Okay, b plus n times b plus n times b plus n times c plus n times c plus c. Okay, all I have to do is get rid of the parentheses, which I think I can just do like that again. Rewrite, get rid of those parentheses. There we go. I think that's it. B plus n plus b plus n plus b, plus n plus c, or plus n times c, plus n times c times c. Yeah, there's this. Okay. Let's go. Wow. That was a lot. Here's my solution. Induction C. Rewrite, add 0. I mean, it's hard for me to visualize what he's doing without actually being able to see the goal update. But wow, that's a hell of a lot shorter. Induction C. I went with induction A. Anyway, let's move on to the next one. So we just proved add multiply, which proves that we proved the distributive property. Add multiply is just as fiddly to prove with induction, but there's a trick which avoids it. Can you spot it? What? I suppose. Yeah, okay. So we just proved this one, and now we're trying to prove its opposite. I think I can prove this without induction. I just need to let me... yeah. Let me first get rid of the parentheses, like I did last time with my little trick. Wait, no, is that not it? Oh no, it won't work because the things in parentheses are being multiplied, but not added. So I can't get rid of the parentheses in this one. At least not until we have some associative property for multiplication. Where should I start then? What do we have? We want to prove the opposite of this. There's a trick to avoid proving it by induction, and I would like to find it, because proving things by induction is hard. No, not successors. Oh, that's it, I think. Rewrite. We're going to switch these around. I think this should work. Whoops. There we go. We just switched its form around, and now we can use this one. And now they're the same. And we avoided induction. Wait, did we not? Hang on. Am I blind? Oh, I need to actually read before I jump to conclusions. Yeah, C times A plus C times B. Okay, we just need to Oh, no, wait, actually we could go back. We could switch them around before. No, we can't. That won't do anything. But we can still, all we have to do is we just use we just use this again. Multiply commutative, and that becomes like that. I really wish I knew what any of this meant and why it doesn't just update the goal. Why doesn't it just repeat for each of them? What is this? Further goals. A times C plus C times B equals A times C plus B times C. Is it the same thing? No, it's different. It's just like every variation of C times A plus it. I don't know. Anyway, I'll just stick to typing it out multiple times. Now we have them. Wait, no I don't. Wait, what? Why did you went from switching these around, which is what I wanted. Now I want you to switch these around. But instead he switched, what did he switch? Wait, it went from C times A and A times C to A times C and A times C. Okay, I guess I need to specify there we go. Now they're the same. Here's my proof, he says, or she. Rewrite, multiply, commutative. Oh, okay, same as me. He just put them in one line. And then repeat, multiply by C, multiply commutative C. So wait, so he got to here, and he told it to repeat rewrite. Hang on, I forgot what it said. Repeat rewrite multiply commutative C. So what did that do? It changed the C and the A around. It didn't change the C and the B around. Further goals? I don't understand this. And then he just uses the reflect as if there's no more. But when I type in the same thing, I get this weird list of things. And I don't know why that is. Right? When I type that in, it stops at the first one and then shows me this, further goals. Which, yeah, these two options are the same thing. I don't understand that. It's doing what I think it should do. It's switching around these, but it's doing it over here in these. And why are there two of these that are the same? And why doesn't it affect that? I don't know. I don't know. I don't know what this means. Oh, well, I can just type it in and it'll... Okay, I don't know. I don't understand that. We're on level 9 of 9. Now we have enough to prove that multiplication is associative. The boss level of multiplication world. Good luck. Okay. A times B times C equals A times B times C in parentheses. Where do I start? It looks simple. Deceptively simple. Let me think. So what is it asking? It's, oh, well, A times B. I should imagine parentheses around these, since it's going to do the first ones first. It's going to multiply A times B first, and then C. And I want to prove that that's the same as multiplying B and C first. So A and B are being multiplied first. I think we need to use induction. I think we need to... Yeah. Induction. We'll do C this time. I think that's what they did last time, and it was the much simpler answer. Anyway, yeah, so anything times 0 is 0, of course. So rewrite multiply 0. Repeat. Wait, am I being silly? Wait. Oh my goodness, was that it? Was the reason that it was only doing the first one because I was clicked inside of it? If I'm clicked in here, then it looks like it's only done the first one. I have to click to the end of it for it to have done. No, it didn't. It didn't work. Look, it's still b times 0, which if it had repeated multiple times, then it would have turned b times 0 into 0. Do it again. Wait, if I just type repeat, and then even though it doesn't look right, I can do reflect, and it's done. Wait, what? 0 equals 0. I have to click down? Is that it? As long as I'm on the same line as it, it shows it looking like this, but as soon as I press enter and go down to the next line, now it shows it as it should be. Okay. I guess that works anyway. Great. Next. Successor n. How to deal with successor n. Oh wait, let's look at our induction hypothesis. A times B times n can be turned into A times B times n. It's like last time we have the successor n, and we want to get rid of... Now, how did I do that? I've already forgotten what I did last time I was in this situation. We gotta get rid of the successor n. This one here should work. Oh. If I just repeat this, and then I have to press enter in order to see the result. And now we have A times B times n. Remember, imagine a parentheses around these, because they're being done first. A times b times n plus a times b. We have b times n is being done first, plus b times a. Those seem different to me. Or here, let's use the induction hypothesis. A times b plus n, a times b times n. And we can get something much closer. Right, rewrite. We're closer. A times b times n plus a. We have plus b. What are we doing with a plus b? Oh wait, that looks... What if I didn't repeat this? What if I just did the first one first and left this as is? Still not sure where we get the plus a from. Right, okay, we solved this, and then we had this one left. Let's go back, because I'm stuck. What we should do next is... we have an a times b times the successor of n, b times the successor of n. What else can I do to get rid of the successor of n? I don't think there's anything else I can do. We get to here. Oh, that's where the plus a came from. So now we have a times b times n plus a times b. I could use this now. Yep. That did something. We have a times b times the successor times n, and over here we have the successor of n, and then we have an additional Was I misreading it before? I thought I had plus a. We have plus a times b, which is different. What will this give us? I'm pretty stuck. But I feel like I'm so close. A times b times n, a times b times n, and then we have a plus b over here, and a plus a times b over here. What can I use? Wait, can I use this? Can I use this somehow? This somehow. Let me go back. Yeah, what if I use that? Yeah, rewrite, add, multiply. No, I can't do that anywhere. Can I use it here? No. Uh, we changed the successor of n into n plus a and n plus b. I need to walk through this step by step. First, we're going to take this, the successor of n. A times b times the successor of n becomes a times b times n plus a times b. Right, we're putting this on both sides. Right, it's the successor of a times b times n, so we're just adding another a times b. what can I do with that then? Oh wait, could I have used this instead of... I tried this one, I didn't try this one. Let me see what that does. Or if it'll let me. No, it doesn't like that. Wait, can I not use this here? Because technically, I'm supposed to imagine this with parentheses around it. This is basically this. So if it's that not, it won't let me do that? No, it doesn't like that. Okay. I guess not. I thought that would work. What next? A times B equals B times A. I don't know if that helps us. That doesn't help. This is what we've already been trying to use. What can I do? I can turn these three into this, A times B times N. What if we do... No, what am I looking for? This one. But I only want to affect the last one. So we'll say, wait, there's 1, 2, 3, 4. No. 1, 2, 3, 4, 5. Okay. Then if I do this... Now we have n times b plus b. That's the same thing. I just went through the work of doing it backwards. That ends up with the exact same result as if I had just done this. Wait, no, it is slightly different. This is b times n plus b. I have n times b plus b. That doesn't help us very much, though. Is this anything? A times b times n, a times n times b. Oh, we're in addition? We're not in addition. Can I use this now? No, I thought that would work here. But it didn't. Oh, but this has to have something to do with it. Let me go back again. What can we use? Really seems like we're supposed to do that. Okay, no, we definitely need to use this. It's just successor n. Getting rid of the successor on the n is really giving me trouble. What can I use to get rid of a successor? Obviously not that. That's not what I'm looking for. This is what I've been using. You could do it reversed. Oh, this is the reversed version of... This is the one I've been using. That's not what I'm looking for. Wait, let me... Can I rewrite? Whoops. There we go. Okay. What can I do? I don't know. I don't know about this one. I'm very... Should I just try a different letter? Let's try a different letter. Let's start over. Let's try A. I'm just... Man. It seemed like I was on the right track, but I just could not figure out what to do next. 0. 0 times anything. That's anything times 0. 0 times anything. Rewrite. 0. Multiply. Repeat. Okay, so that was exactly as fast as last time. Let's see if this is any easier. Successor of n times b times c or yeah, the successor of n times b times c is the same as the successor of n times b times c time, or it's b times c times the successor of n. We're doing these ones first versus doing these ones first. It's pretty much the same as last time, but maybe it'll be easier. We just need to get the successor of n out of there. Yeah, with this one. Okay, n times b plus b. Okay, hang on. Let me do this one at a time instead of repeating them all at once so I can actually see what's going on. N times b. Yeah, the successor of n times b becomes n times b plus b. Oh, we want n times b times c. What do we do? What do I do about that? Can I do something with the addition? What can I do? Would that do anything? I feel like no. No, it does not. That works, but I don't think it really helps me at all. This one is tricky. I'm really stuck. Should I try that? Maybe. successor equals add 1. Now what? At least it's something new. But they are the same on both sides now, at least. We have a 1. We have the same symbols on both sides. We have n. We have a 1 on both sides. What else can I do? What can I do with that? Can I get rid of the parentheses? No, that didn't work. I don't think that helps me. That's something I could do at least. Wait, let me think. What am I doing? We can turn 1 equals the successor of 0. So that's something. And then we can no, the successor. Oh, the opposite one. Add successor. Wait, we might just be going in a circle. Because now if I get rid of the... If I get rid of the 0, we're back to successor n. We're exactly where we started. Okay. Man, was there nothing we could have done in there? We went in a whole circle. Ended up right back where we started. What about, is there anything else? Or is this a total red herring? A wild goose chase. Hmm. hold on. Maybe a times surely I can use this now. Oh. Yes, okay, it actually did something. N times b plus 1 times b. Okay, that's something. And anything times 1 anything times 1 is itself. What is it? Okay, we have n times b plus b. We could. No, that doesn't do anything. N times b plus b. I might be done for tonight. I think my brain's done. I will continue this tomorrow. That worked last time. I'll come at it with a fresher brain. Goodbye.